Hello everyone, welcome to Helm of Science. So I hope that all of you are preparing for your upcoming exams. So today the topic that we will be discussing, it is the topic of class 11. It is the first chapter of your class 11 syllabus, that is the set theory. Okay, so let's get started with this. So the first thing when we study this set theory that comes in our mind, that is the question, that is, what is a set? What is a set? So write it down. A collection of well-defined objects or numbers which are independent of order is called a set. Okay, so what is a set? It is a collection. It is a collection of well-defined. This is what is very important. So it's a collection of well-defined objects or numbers which are independent of order. That means the order in the set is not important. Okay, order of the elements of the numbers that we are putting inside the set is not important. Okay, so now we have to know that what is the meaning of this term well-defined. Now suppose, for an example, to understand the term well-defined, suppose example I am giving, that I am telling you to form a collection of form a collection of odd numbers. Okay, now if I would tell you that to form a collection of odd numbers, all of us can form a collection of odd numbers, because all of us know that what are odd numbers. Okay, so it can be easily formed. That means we can form a set of a collection of odd numbers. But if I tell you that form a collection of best teachers in India. Okay, if I would tell to form a collection of best teachers in India, now that is to be formed. Okay, so it will be not difficult. Why? Because this is a contradictory sentence. Okay, different people will have different opinions on this, because according to you, you can have best teacher. Okay, another people will tell that he or she is my best teacher. Okay, so different people have different opinions about their best teachers, so it will not match. Okay, if I would say that form a collection of odd numbers, now if I would form a collection of odd numbers, what will I form? 1, 3, 5, 7. Okay, so all of us will form like that. But if I have to form a collection of best teachers in India, if I have to form, so I will form my best teachers, you will form your best teachers, that is, you will form a set of your collection of best teachers. So it is different. So we will call this sentence as a well-defined sentence. Why? Because it is defined for all. Okay, and this sentence, it is not well defined. Okay, that is, it is not same for all. It's a contradictory sentence. Different people will have different opinions on this. Okay, like for example, if I would say you to form a collection of most talented writers of India, it is also a contradictory sentence, because different people will have different choices of writers. Okay, like that. If I have to form a collection of all the vowels in English alphabet, it is a well-defined sentence. Why? Because there are 26 letters in the English alphabet, or here it is saying to form the collection of all vowels. We know that the vowels are A, E, I, O, U. So all of us will form the set of that AEIOU. Okay, so that is a well defined. Okay, so I think you have got that what is well defined and what is not well defined. So what we have done, that a collection of well defined objects or numbers which are independent of order, that is not depending upon the order, it is called a set. Okay, now we come to the representation of a set. Representation of a set. Okay, so what is this? So the first representation, there are two types. The first one is the roster form, or it is called the tabular form. Okay, so here in this roster form, not in roster form, it is general set. These important points you have to note it down. Set is denoted by capital letters. Before representing the in a roster form, this needs to be remembered. So set is denoted by capital letters. That is, suppose A comma, that is A, B, you can say X, Y, P, Q, like that. Okay, so set is denoted by capital letters. Okay, now what is the structure of this roster form? We will talk about the structure of roster form. So how we will write this? So we will write the set, that is we will denote the set as a capital letter, that is with capital letter, that is suppose I take the set A, I denote the set as A. Now in roster form we write it in this way, that is we write the set denoted by capital letter, suppose here A, then we write a second bracket. Okay, we put a second bracket, and then we write the elements that are included in the set by putting commas like this. Suppose here 1, 2, 3, 4, like this. This is the roster form. So these are called the elements of the set. These 1, 2, 3, 4 are called elements of the set. Elements of set, you can say here A, set A. So in roster form, we write it in this way, that is suppose a set A, and then we put a second bracket. Then we write the elements of the set and put commas after that. Then after it is ended, it is we put a second bracket. Then okay. So this is the roster form. Okay. Now to write this for a set, we have to note a thing, that is in set repetition of elements or numbers is not allowed. Okay, in set repetition of the elements, suppose I have written in a set one time, that is if I have write it like this, that 1, 2, 3, 4 in a set like this. Now further I cannot write 1, okay, because I have written it once. So that is, it is telling that repetition of elements is not allowed in this. And the next one that we have written in the definition, that is order of the elements, order of the elements in a set is not important. Okay, that means the order is not important. If I write suppose a set denoted by A, suppose 1, 2, 3, 4. Now if I write this set in this way, that is 2, 3, 4, 1. Now this and this set is same, because here nothing is different. Here the elements are 1, 2, 3, 4. Here it is also 1, 2, 3, 4. Here it is also 1, 2, 3. But here the orders are different. But In set, there is no such case that order will be different and the set will be different. Okay. So order is not important in a set. Okay. Now some examples to form a set. Suppose some examples of set we can write that we can write form a set of all vowels that I was telling you before, vowels of English alphabet. Okay. So how we will write this set? It is telling that form a set of all vowels of English alphabet. So we denote the set, suppose by capital A, then we put, now we have to write it in roster form or tabular form. That is like this. We have to put a second bracket. Then we have to write the vowels that we will have. That is A, E, I, O, and U. And we have to write in between commas. And then we have to end this bracket. Okay. So this is the set. This is the set that we needed. Okay. Now next, if I have to form a set, suppose form a set of first 5 whole numbers. Okay. Now what are whole numbers that we know? It starts from 0. So suppose I take a set, suppose I denoted it by B, capital B. Then we put bracket, second bracket. So what are the 5 whole numbers? First 5 whole numbers, that is 0, 1, 2, 3, 4. So this is the set. Now, since the order is not important here, so you can write it in this way also, not just by maintaining the sequence. You can write it in this way also: 4, 3, 2, or 4, 2, 3, 1, and 0. This is also correct. Why? Because here order is not important in the set. Okay. Now, next, another important thing, that is what is cardinal number of a set. Okay. So cardinal number of a set, or we call it order of a set, or it has another name, that is the number of elements in a set. Suppose the set is, suppose A, or in a set. So we denote this cardinal number or order or this as it is represented by n of that set. Suppose the set is represented by capital A, so it will be n of A. If the set is represented by capital B, then it will be n of B. So what does it represent? This is represents number of elements present in set A, and this represents the number of elements present in set B. Okay, that is what is the cardinal number of a set. It is the number of elements present in the set. Okay, it is represented by n of that set. If I just represent a set by capital A, then cardinal number of that set will be n of it. Okay, so the set just we have formed, so we can find out the cardinal number also. Okay, so here, if you see carefully, this is a set. This is a set A. Okay, if this is a set, it has how many elements in the set? A, E, I, O, U. So here 5 elements are present. So I can say that cardinal number of this set A, suppose NA, is equal to 5. Why? Because here 5 elements are present: A, E, I, O, U. So in this set, out of the bracket, how many elements are there? 5 elements. So the set contains 5 elements. So cardinal number of this set is 5. The next also, it is also cardinal number of the set is 5 because there also 5 elements are present inside the set. Okay. Now we come to the next representation. That is, the first one was roster form or tabular form. The next one is set builder form. Set builder form. Okay. Now, what is the set builder form? What is the structure of this? Let us understand first. Now, in set builder form, we write it in this way. That is, we represent this way. It is, we write the set, suppose capital A. Then we take the second bracket. Now, here we take a variable. Suppose X or whatever the variable is given. Here we take the variable. Okay. That means whose value we have to consider in the set. That variable is to be taken in this. Then we put a like colon. Okay. Or you can use such that this bar sign. This is called such that, or you can write this colon. And then we write a condition, that is here the box that I have created. Inside this, you can write it down. We write by putting commas or some properties, that is here properties. In this box, we write properties followed by the variable. Okay, we write it in this way. That is, in set builder form, the structure is we write the set denoted by capital A or whatever the capital letters, that is A, B, X, Y, P, Q, anything. Okay, so here the structure is we write A, then we put a second bracket, then we write the variable, that is which whose values we have to consider in the set. Next we put a colon, and then we write the property that is followed by the variable. Okay, let's take an example to understand it in a better way. So suppose example, so it is given a set A, it is given X such that, or you can write colon as you wish. It is given, the property is given, X is a whole number. Here we have to end this bracket, whole number. Another condition is given, that is X should be less than 3. Okay, so it is given that A is a set where X such that X is a whole number when X is less than 3. Now this is the representation of a set in set builder form. Now this set I will represent in roster form. Let's see how. This is the set builder form of this set A. Set builder form. Okay. Now you have, if I had to write this set in roster form, how will I write in roster form? Now see carefully. It is given that X is a whole number and X is less than 3. The condition is given. So whole number starts from 0. We know that 0, 1, 2, 3, 4, and all the way. So here X is less than 3. So we can take the only the elements 0, 1, and 2. Okay. So we can take only the elements, that is the X we can take, it is 0, 1, and 2. So in roster form, we will write like this, that we will denote this set as capital A, and then we put a second bracket, and then we will write the elements, that is 0, 1, and 2. Or you can write in 2, 1, 0 or 0, 2, 1. Order is not important. Okay. So this is the representation of this set in roster form. This was the set builder form, and this is the roster form. Now you can see here that cardinal number of this set is what? Number of elements present in the set is 3. So here cardinal number, that is n of A is 3. Okay. Another example we could have, that is, if I just denote a set with capital X, it is given that here alpha, the variable alpha, such that alpha is a root of the equation x square plus 5x plus 6 equal to 0. This is the equation. And another condition is given that alpha is greater than minus 3. This is the condition. So this is the set. It is the set builder form of this set X. Okay. So we have to just write this set in roster form. So how can we write this? Since, see here, it is told that alpha is a root of this equation x square plus 5x plus 6. So at first, just find the roots of this equation, that is x square plus 5x plus 6 equal to 0. So we can just break this as x square plus 3x plus 2x plus 6 equal to 0. Or we can write x into x plus 3 plus 2 into x plus 3 equal to 0. Or we can write x plus 3 into x plus 2 equal to 0. Okay, so what value will of x we will get? This x equal to minus 3 and x equal to minus 2. That is, here actually alpha is 1. Alpha is minus 3 and alpha is equal to minus 2, since alpha is the root of this equation. But there is a condition given. You can see that alpha should be greater than minus 3. Therefore, what? Therefore, this case is cancelled. This cannot be taken. Okay, because alpha is greater than, not greater than, equal to. Alpha is greater than minus 3. So the set we will get in roster form of this set, that is in roster form. In roster form, this x I will get as only minus 2. Okay. Now, in types of set, we will learn that this type of set, that is in the set where one element is present, it is called a singleton set. Okay. Singleton set. In types of set, we will learn this. Okay. So here the number of elements is 1. So here obviously cardinal number of this set X is only 1. Okay. Whatever we have done, that here alpha was greater than minus 3. So minus 3 is obviously greater than minus 3. So the root that we have got is minus 3 and minus 2, but we cannot take minus 3 as alpha is given in the condition, that is it is greater than minus 3. So in the set, in the roster form, we will take only the root minus 2, and it is the only root. So in the set, we have one element only. So it is a singleton set, and the cardinal number is obviously 1. When it is a singleton set, always remember the cardinal number in the set is 1. Okay. Now, in later parts, we will be using some symbols. So at first, just learn the symbols, that what it represents. Okay. So important symbols. Write it down. Important symbols. Okay. So here we will write symbol, and here we will write meaning. Okay. So the first symbol, that is like this colon type, or you can write this bar. So just now I have told you that it represents such that. So the symbol of this, the meaning of this symbol is such that. The next symbol that we have is like this. Okay. Now this looks like some of the epsilon that we have learned in physics also. So here epsilon like this. So this in maths we call it like this, that this symbol represents the meaning belongs to. Okay. If I will write that x belongs to some 2, 3 like this, so you can see that this symbol represents belongs to, that x belongs to this interval. Okay. Belongs to. Okay. So this symbol represents like this. And the next symbol, just the opposite of this. In set theory, this is enough. So the next symbol we have, that is does not belongs. Okay. Does not belongs. Okay. So these three are the important symbols. Now next we have to write some important sets. You have to know, write it down, some important sets. Important sets. Okay. The first set, that is we denote it by capital W. When we are writing a set, when we are denoting a set, please try to avoid some letters that I will write right now. That is W, N, I, Z, Q, R. Okay. So please try to avoid this, because this itself represents a set. Suppose the first one that I am writing, it is the set, that is the set of whole numbers. W, capital W, it is noted by capital W. It is the set of whole numbers. Set of whole numbers. Okay. So set of whole number means it will start from, if I write it in roster form, 0, 1, 2, 3, 4, up to there. Okay. So this capital W is the set of whole numbers. Okay. So if anything is written in book, any book, that capital W, we will just think it as a set of whole numbers. Okay. If anywhere is written like this. Next we have capital N. Now what does it represent? It represents set of natural numbers. Okay. So capital N represents set of natural numbers. So natural numbers means it starts from 1, 2, 3, 4 up to. Okay. Okay. So this is the set of whole numbers and natural numbers denoted by capital W and capital N respectively. Now the next set that we have is the set of integers, and it is represented by capital I or capital Z. So it is the set of integers. Okay. So set of integers means from here it is -1, that is you can say -3, -2, -1, 0, 1, 2, 3, and up to infinity. Okay. So this is the set of integers. Now we come to the fourth set, that is represented by capital Q, and it is the set of rational numbers. All of us know that what are rational numbers. Thus I'm writing this one in set builder form, that is suppose x such that x is equal to p by q. This is a definition of rational numbers, where p and q are integers and q not equal to 0. Okay. So this is the set builder form of this set, that is a set of rational numbers. Okay. Now the fifth one that we have is the set of all real numbers, and is denoted by capital R. Is the set of all real numbers. Okay. So this is the set of all real numbers, that is we have from -infinity to infinity, all the numbers. Okay. Like this, all the real numbers. Now next that we will have, that is it is denoted by q bar. It is the set of all irrational numbers. Okay. Set q was what? It is the set of irrational numbers, and q bar is the set of all irrational numbers. Okay. Now how can we get these irrational numbers, that is set of all irrational numbers? Simply we will just eliminate the set of rational numbers from the set of all real numbers, and then we will simply get the set of all irrational numbers. Okay. So set of all irrational numbers is basically r minus q, that is we have to subtract the set of all rational numbers from the set of all real numbers, then we will get set of all irrational numbers. Okay. So these were some important sets. Now another thing that we have to note, that is note, that is, whenever we will write, or whenever it is written that it is r plus, we have to just think that it is what? It is positive real numbers. Positive real numbers. That is, it is starting from, that is, it is actually what? It is like this, from 0 to infinity, but not including 0. Okay. Next we have, if somewhat is written q plus, it means positive rational numbers. Okay. This we have to know while doing the chapter set theory. Various sums will come where it will be written like this. Okay, so r plus means positive real numbers, q plus means positive rational numbers, and I plus means positive integers. Okay. Similarly, if it is written r minus, so r minus means negative real numbers. Negative real numbers. Similarly, q minus is negative rational numbers. Okay. And this I minus is negative integers. Okay. Now another thing you remember, that I plus is same as the set of natural numbers, because I plus means it will start from 1, 2, 3, 4, and natural number is also the same. Okay. So set of the positive integers is equal to the set of natural numbers. Okay. So these are the some important sets that we have to remember while doing this chapter, and we will come across various types of question where it will be written in this format. Okay. So today up to this, so I think all of you have understood the concepts, that is what is set, what is the representation of a set, what is set builder form, what is roster form. Then we have taken some examples, and then we have learned some symbols to represent, and then we have learned some important sets. Okay. So in the next class we will start with the types of sets, that is, we have null set, that we have equal sets. Okay. So we have equivalent set, singleton set, finite set, infinite set. So in the next class we will talk about that. So I think you have liked the video, and if you did, please share it among your friends and subscribe to our channel Helm of Science for more of such videos. So until then, keep studying hard. Thank you so much for watching.